I'm senior software engineer at Andersen, and today I will talk about OCR and how to do it with Tesseract and OpenCV. Recently, I had to perform some OCR tasks on one of our projects. We needed to scan documents. By the way, do you know what OCR stands for? And of you. Okay, great. I'm really glad that you came here despite not knowing what we will be talking about, but no worries. I will explain it soon. So OCR stands for Optical Character Recognition. It's a set of technologies that used to read text from paper, images, even from video or whatever, and to transform it to some machine-readable format that allows us to index it, to search it, and so on. And the technology we will be looking today is Tesseract, and as additional to it, we will also try OpenCV to do some pre-processing of images. So actually, again, this clicker is not working. So OCR technology started a bit earlier than the first computer was built, actually. So on the left, you can see Optophone that was developed to help blind people to read text. It used photosensors to read black fonts and to transform it to some kind of melody. You know, every character had its own chord that was played. And on the right is the principal schema of Emmanuel Goldberg's statistical machine. It was invented to automate telegraphing. It read cards with text and then telegraphed them automatically. And as you see, it was developed more than 100 years ago, and still, despite that century and even more than century of constant innovations, we still use some of ideas that was initially invented by these inventors. And yeah, so and we still far from perfection. OCR technology still is not ready to be as reliable as human, but it evolves and evolves rapidly in modern times. So what we need to do OCR with Tesseract? So basically we need Tesseract. It's OCR engine. It's open source OCR engine that was developed in I believe 80s by Hewlett Packard, and now it is mainly maintained by Google. And for now, it's probably the most advanced open source OCR engine. It's the most accurate one. It supports more than 100 languages, and you can train it to support any language that you want, even if you just invented one recently. You can train Tesseract to support it. And to do image processing, Tesseract uses Electronica. It's mostly educational library to perform image processing, but Tesseract relies on it heavily to do some pre-processing, to help normalize the image, and we will try it also. And to further improve Tesseract's image recognition, we will use OpenCV. Actually, OpenCV is a really good open source library for computer vision. It's useful not only for OCR, but for various computer vision tasks. It has more than 2,000 functions, and you can use it for almost everything from real-time video stream processing to OCR and so on. So to understand how we will do the character recognition, we need to understand Tesseract flow. So basically, our input image goes to adaptive thresholding, which is basically binarization of image. When we take our colorful image and just turn it to black and white image. And by black and white, I don't mean grayscale image, but purely black and white. It will consist. It will contain only black and white pixels. No grayscale at all. And because images tend to have different brightness on different parts of it, especially photographs, Tesseract uses adaptive thresholding. It means that it will it will look for the darkest part of the image and will treat them as a text. That's why we will need actually to do preprocessing with OpenCV, but I'll tell about it later. After that, Tesseract performs layout analysis. It tries to figure out where is the text. It then splits our image to blocks of text and then performs voice recognition on these blocks where it tries to understand which symbols are actually a word. It will look for spaces between symbols, and Tesseract is actually really good. It's probably one of the best models at discovering spaces between words. Other models are not so good at splitting words. And after that, it uses contextual analysis to understand basically as human does. It will look for the context. It will look for the dictionaries to see if the word that it recognized actually a word. Probably it will change it on this stage. And after that, it will format it to our desired format and just output the text. But this is the basic flow. We will see that it has its own flows. And with, sorry. Okay. For some reason. Okay, no matter. So with advanced flow, we will do some pre-processing, and the first three parts just parts when we would use OpenCV. OpenCV is widely used for noise reduction. It's a process when you remove various noise, like some parts of image that are not text. You will probably want to treat your image like a 3D picture using Z buffer your colors and just pick the colors that will look like a text. And after that, we will use scaling. Scaling is actually crucial to recognition with Tesseract because Tesseract is highly sensitive to image DPI. And rule of thumb is your characters should not be less than 20 pixels high, but they also shouldn't be more than 30 pixels high. Because with small images, it just don't have enough information to perform the OCR. And with large images, it will not be as effective as with just good quality pictures. And after that, usually our scans, photos they are not oriented perfectly. They have some skew, and we will use dedicated function for the skewing. I'll also show how you can write your own function to do more customized skewing using OpenCV. And on that stage, you probably would like to do some normalizing of the image, because image can not only be skewed but morphed. It may have some distortion. I will not speak about it because it's a quite complex topic by itself. But using OpenCV, you can perform that task too. And after that, we will just follow our normal Tesseract flow and receive our output text. Basically, it is initially this meetup was planned as workshop, so I will show you how Tesseract works and how we can improve its recognition quality. So to start with, let's try just our basic Tesseract. So on my images. Okay. So okay, I think it should work like this. Do you see it perfectly? Should I make it bigger? Okay. So good. So basically, I have already Tesseract installed, but you may want to install it. It's not worth mentioning because you just download the installer and install. With that, we can just use our image. We will tell that we want to scan this image. We want to put output to our output txt, and we will use language English. Yeah, Tesseract will perform the recognition, and as you see, we have our output txt that is basically our receipt scanned by Tesseract. So, yeah, as you see, it's not perfect yet, but it's already good enough to get some text. You can see some artifact like this one, because probably Tesseract was not trained on this font, and it's also important for it. But overall, it's already good enough for some basic tasks. But let's switch to the code and do some more advanced character recognition. Sorry. Yeah. Here we can do basically the same. I've prepared some examples here. So to start with, to use Tesseract in Java, you need a special wrapper that will build a bridge between Java and C++, because Tesseract is written in C++, and you will need GNI to work with it. I prefer bytecause Tesseract platform wrapper, and to work with it, we will need also Java CPP, which has several useful functions that we won't use directly, but we need them for Tesseract. We also will need electronic platform because Tesseract uses it, and we will also use some of its functions. And as I mentioned before, we will also try OpenCV to improve our OCR. So to do character recognition with Tesseract, since it is native library, we need to initialize it with special function. Here I just pass to our folder with our models, and I specify that we want to try detect in both English and Russian. Here we will try with our models. Tesseract has several models. Here I'll be using the best trained models. They're not the fastest ones, but they give us the best recognition quality. If you need, if you will value performance over quality, or maybe the quality will be enough for you, you may try different models. There's standard ones that you can use like this, and you can also download fast ones. I didn't download them, but they just called like language was fast. These models are used by Tesseract to recognize characters. Also, we will specify our page segmentation node. I will talk about them later. For now, we will just stick with auto. And then we need to read our image, and we will need to convert it from matrix to pix, because pix is format that used by Electronica, and matrix is format that's used by OpenCV, and imread just a real convenient function to do image read. I will show this function later, but no, it's not so important. Then we just set our image to be recognized. We do several operations here, but first I want to skip these operations, and we will try to recognize our initial image in the way that Tesseract recognizes it. So we have sorry. We have this image that my girlfriend sent me from her trip to Moscow, and it's just a regular receipt in Russian, but it has some English characters here. So let's try to do recognition with Tesseract as it is. Yeah, so as you can see, it was actually good enough for, it was actually much better than I expected. It was actually able to understand where to use English and where to use Russian. You still see that there's some flaws, but overall it's still good enough. But let's try to further improve our recognition. And for that, first of all, we will Are we using the correct one? Yeah, we're using the correct one. I'll just comment this part because we won't need it for now. And here we will try to deskew our image because as you could see, original image has a little skew that probably interferes with Tesseract's recognition process. Sorry. And for that, we will use fix the skew function. It comes with libtonica. It's just general skewing function. It doesn't require any. So where is my mouse? It doesn't require any additional parameters, just image. And here you put number of bytes actually used in the image. Since we're using colored 32-bit image, we use 4 as 4 bytes. And we just needed to visualize how it works. And yeah, that's it. So let's just change it back and see what will happen. Sorry. We are probably I launched okay. So here we can see that with the skewed image, we have been able to read the header of our receipt, and there probably has been some improvements in the middle of it. And let's see how our the skewed image looks. No problem. So here, yeah, probably I've accidentally changed the code, but here you can see our discrete image, and yeah, let's just compare it with our original. So as you see, the queue is removed slightly, but it uses its biggest contour, which is this receipt here, to try to remove the queue. You see, there was not much of it. And with sorry, my mouse is not working. With we also can see how Tesseract tries to understand which image to use. I just need to understand what happened and why I'm getting additional shading here. Yeah, just give me a second. Yes, I know what's happened. Maybe this one. Yeah, good. So looking back at our images, we can see how Tesseract actually sees the image. As you see, it just transforms our image to black and white. I mean, pure black and white. And we're lucky that it's just a receipt, and we don't have to do additional noise reduction here. And here we can see it's from another run, but we can see that Tesseract actually tries to understand which character it picks box for each character and tries to scan this particular box. I will show it to you how to visualize it and how to use it. So here we can additionally look for our chases. This code was for boxes, but this one will show us what our other chases the Tesseract had, and what confidence level was for each picked character. To turn that on, I will have to set LSTM chase mode to 2. It's just in the documentation. I don't know what the value is for. And actually, Tesseract is not really good at describing its variables, so you will need to try several ones before you will find the one that does what you need. Because some variables here are used for older versions of the engine, and since we're using our newer engine, we don't actually need them. But we need the newer ones that are not documented well enough. So with that, we need to use our result iterator. We just get it by get iterator function. And as we're using native wrappers here, we have to work with C++ pointers. So we're getting pointer to our string, we work with it, and then we iterate pointers to our choices. And here for each choice, we again have our pointers that reference to our choice string. And here we will just print them to our console log. So let's run and see what happens. Okay. So probably for some reason our mod didn't stop. Probably we have some interference here. Yeah. So Okay, let's do it later. I'll figure it out. Now let's do the boxes then. So here we use our iterators to get bounding box for each character recognized by Tesseract. And since we did our skew, we will draw them with rectangle function on our discrete image, but not the thresholded one, but just the colorful image. And let's see what will happen. Yeah. So here we can see our bounding boxes. So I made them green deliberately. But as you can see, Tesseract tries to understand as character every black point on our image. So if it's small enough to be considered as a character, it will try to recognize it, and you can see this picture. That's what happens. Sometimes it doesn't recognize because here it's just complex layout with several columns, and Tesseract is not really good at understanding columns. But as you can see, it still tries to treat them as single lines. Yeah, you can see that here it tried to recognize this QR code also. Yeah, and for better recognition, you sometimes need to improve your your models. I will not teach you how to train them for your phones because it requires a bit more data than I have. But I will show you how to add additional words to your dictionary. So let's try. Actually, probably I'll want to reshare my screen because it's really inconvenient to show it like that. Does it work? Okay. So again, we have. Do you see it well? Should I make it bigger? Okay, good. So here you can see our Tesseract in all its glory, and what we're interested in is test data folder where we have our models. It's not the models that I used in our example. We keep them here, but it's the default models that they distribute with Tesseract. So let's try to improve our models that we have here. Let's try with our image best. For that we need our that. Yeah, we need to put it here. We actually can do it everywhere, but it's just more convenient here. And here I've already prepared operations that we need to perform. First of all, we need to decompose it and to keep our original model in touch. I will decompose it to another one. And you can see that we now have several files that represent different parts of the model. And now we can add new words that I prepared here for the receipt. And then we will add them to our model with this command. Basically, it adds, oh yeah, important part here. We need to keep all our word list because it will be added to the model as it is. So I've downloaded original training data, and here we can just add our words to this training data. And after that, we will need to compose it back. So with in train data, we will put it to, sorry, yeah, like that. So yeah, we will have our input, sorry, yeah, we will use our inc word list to put it to English-based LCM word doc. Doc is basically a dictionary file, but compiled formatted in the way that model works with. And unit chart set is just a chart set for the model. So here we will add our words to the dictionary. It rewrote our dictionary, and now we need to repack it back, and let's just use our combined test data. And now we have our updated model that will use additional words that we have added to the dictionary. Now we just have to get this train data. I don't see it though. Yeah, we just have to use this train data, put it to our folder, and we can use it in our model. Here, instead of just English best, we will use English best. Probably it won't give us much improvement here, but sometimes it becomes really helpful because you probably just need to add words that Tesseract doesn't know to your dictionary, and it will help it to understand them. You probably should add index to Russian dictionary, but okay. So that's basically about updating Tesseract models and adding new words here. And let's try our skewing with OpenCV. For that, we'll use this file where we will use this model. Here I try to use OpenCV. Yeah, I try to use OpenCV to do the scheme. I'm not really good at it, but I wanted to show you how it's done with OpenCV. Here, as you see, I'm still reading the image, but I read it in grayscale, and then I do thresholding myself. I use auto thresholding. It's adaptive thresholding algorithm. We just put our highest bit to black, and everything else is basically default. You can put threshold value here, and you can change your mask here. You can make it bigger, for instance. And here we're trying to find contours. As you remember, we had these nice boxes that Tesseract had. With find contours, we will find every black part of image that forms a contour. There are several algorithms, but this one will try just to find the biggest contour with chains. And then for each contour, we will try to try to find its rectangle, which is just this one. And then we will see we will look for rotation angle, and then we will calculate median rotation angle to perform our just affine transformation for the image at all. So let's try running it and see what will happen. So here, okay. Yeah, as I told, I'm not really good at it, but this skewed image is how our OpenCV algorithm tried to skew our original image. Let's just compare it with the original to see if there's any difference at all. Yeah, probably not big difference, but yeah, I'm not really good at writing out my own skew algorithms. So that's it. I really want to show you how to get those choice iterators. Probably let's try with this version. Let's see if it will show us. Okay, actually, yeah, I almost forgot about page segmentation modes. Here, so you see, I tried to scan word address from one of our receipts. Originally, it looked like that. And if you remember, Tesseract was not good at understanding this word in the receipt in the whole, but when we try to tell it that it's just one word, Tesseract used its context understanding to understand that despite this D looked like an A, you see the confidence for A is twice as confidence for D, it still returned us address as a result, because it's just a dictionary word, it knows that. And here you can see that there's different confidence for different letters. And about page segmentation modes. So there are 14 page segmentation modes. You probably will need some of them. So auto is just default. It works most of the time. But sometimes you need to remove all Tesseract specific hacks and try to use its model by itself. For that case, you will use row line. It will treat your image as single line of text. So you can use OpenCV to split image for lines and then feed them to Tesseract one by one. And if it's not enough, sometimes you might want to scan them symbol by symbol. So it's similar char mode. I can show it to you. But basically, it's almost the same as single word. Just Tesseract will understand that image contains just one char, and it will try to recognize this one single char. Same for single word. It just treats all our images just one word and will try to recognize it. And other modes are mostly for working with tables. You can see that the single column vertical text block. It's for yeah, actually there's comments there. It's for images that are vertically aligned, like if your text is written from top to down. And basically, that's it for the basics using that. Oh, by the way, yeah, the scaling. Yeah, the ones that I told you, because this image was a bit bigger, so I needed to rescale it. Basically, that's it for the basics. I think that's more than enough for the introduction. And probably you have some questions for me. No questions? Yeah, sure.
What's the models library? I saw you update the models.
Yeah, so basically Tesseract uses for its newest version, it uses mostly neural networks to understand which image correspond to which character, and it uses trained neural network models. They called long short-term memory models. They contain information about fonts that were used to train the model, about the language itself. They contain different words from the language, and they also contain typical phrases or words or shortened words in the dictionary file. So I showed you how to update those dictionary file, because retraining model is much harder, but updating its dictionary file is just as simple as I showed you.
TXT file containing words, information about language.
Yeah, it's different files. Let me show it to you in. Yeah. So It contains doc files are basically dictionaries. See, it contains different dictionaries for numbers, for punctuations, for words. It also contains char set. I'm not sure if it unpacks here information about fonts, but probably it's somewhere here. Yeah, but you can update these dictionaries. I just updated word dictionary using our own where it was word list. But just be careful because it will change the word list completely. So if you want just to add several words to the dictionary, then you have to download original training data, training dictionary, and to add words to this dictionary, and then to back it to the model.
So it's not only the list of words, special data structure.
Yeah.
Does work good with images when we have non-contrast brightful images?
Yeah, you can try to do.
I mean, when it's hard to make something contrast.
Yeah, Tesseract by itself won't exactly shine at working with not contrast images. It's designed to work with. Well, it's basically designed to recognize books, text from books, from articles, but you can use OpenCV. Sorry. You can use OpenCV to write your own binarization algorithm and to try to remove all the noise from the original image and make it easier to Tesseract to understand where the text is. Yeah.
It's surprising how so little skew can dramatically decrease the result.
Yeah. Tesseract is not good at understanding skew and fixing it. Though it relies on Electronica, and Electronica has the skewing algorithm. For some reason, Tesseract is probably doesn't use it to do the skewing beforehand. Other models, they particularly address this issue. Let's say paddle OCR or easy OCR are much better at skewed image at recognizing skewed images. But for Tesseract, you have to do the skewing yourself.
So, what would be if we try to recognize text from the text with, for example, several receipts with a different skew? Could Tesseract have several?
It will try to recognize something. It will not recognize all, and probably you'll have your data messed up. So for that, I'll recommend you to use fine contours to understand where's your receipts, because you will have quite good contours there, and the biggest contours would be your receipts. And with that, you can just split your image to receipts and use Tesseract for each receipt.
Okay, thank
you. Any questions more?
Yeah,
sure.
Example, you show the image with blue outline.
Yeah, it's boxes.
The first part and last part of the image, and there were numbers between. Yeah.
Sure.
Why wasn't able to recognize the 1, 0 in the
Probably just thought that it's just a noise.
Because in the first part, when we have 10%,
Yeah,
it was able to recognize 1 and 0.
yeah. Sometimes Tesseract has problem with understanding the layout. It's actually a layout recognition problem. It's not character recognition. Probably Tesseract just thought that it's decoration and not the characters. As here it thought that it is a character because it's just outstanding one, and in the line. But here it just thought that it might be a decoration. Like as you see, it didn't recognize this dashes here because it just thought that it's just decoration, just a divider between different parts of the image. Well, if you have problem with that, you can use again OpenCV to find contours, and using these find contours, you will get all your black areas here. They will all added as your contours, and then you can feed each contour to Tesseract to recognize it. You just have to be creative to understand which part of the image is actually a text. You can use additional models to detect text, or you can use mask to detect just long dark areas in the image. This will be your text usually.
Of the algorithms and flows in field iterations to create the best result.
Yeah, and knowing your data usually helps, because if you know that you're scanning receipts, you can do some heuristics to do some preprocessing, and when you have to scan just general data, usually you will have the worst results. So I guess any more questions? Okay, no problem. I never tried that, probably no. I know that Paddle OCR uses GPU to do character recognition, and it actually works faster if you have good GPU. But if you have to rely on your CPU, Tesseract still performs better than Paddle OCR. And besides, Paddle OCR is developed mostly for Chinese character set, and it doesn't support as many languages as Tesseract does. Okay then, so that's it for the introduction part. You can get announcement about our future meetups in our Telegram channels. The link is in the QR code. And that's it. Thank you for coming. Thank you for questions. I think hope.
So guys, for me now.